Hello everyone, let's go over the main ideas from the first few sections of this unit. So I want to make sure that we all have all the skills we need before we get too far into the unit circle. So let's talk about, first of all, your three basic trig ratios are sine, cosine, and tangent. And you might remember SOHCAHTOA, which if you don't know what that stands for, means nothing to you. S is for sine. The sine of an angle is the ratio between O and H, opposite and hypotenuse. So this is opposite over hypotenuse. Cosine is CAH, adjacent hypotenuse. Adjacent over hypotenuse. And then tangent, OA, opposite over adjacent. Now we also have reciprocal functions. Those will come up in a second. I'll get to those in a minute. But right now, let's just start with those three. And then it says a circle of radius 1 is called the unit circle. The radius is 1 unit. So we call it the unit circle. And if you talk about the standard equation for that, just think about any ordered pair that you have that is 1 unit away. So any ordered pair here that's 1 unit away from the origin has an x and a y coordinate. And if you think about this, the Pythagorean theorem tells you that x squared plus y squared equals 1. And that's the equation of a circle with radius 1 centered at the origin. So this is the formula that we're going to use to test to see if points are on the unit circle. We're essentially testing to see if the hypotenuse is 1. So we're going to, here it says show that the point is on the unit circle. So what I need to do is I need to do the Pythagorean theorem and see if I get 1. So I'll a squared plus b squared, see what happens. Radical 3 squared is 3, and 3 times 3 is 9. So that's 3/9. Here, if you square radical 6, you get 6, and if you square 3, you get 9. So 3/9 plus 6/9 is 9/9. Hey, that's 1 whole! That means this point is on the unit circle because its radius is 1. It's 1 unit from the origin. I can do the same kind of thing here where I tell you one of the coordinates, like I don't know x, but I know y is negative radical 2 over 3. And if I tell you that it's on the unit circle, which in these directions I think I didn't copy that, we're going to say it's on the unit circle, so now tell me the x coordinate. So we'll say x squared plus negative radical 2 over 3 squared, and now we know that since we're on the unit circle, it equals 1, which 1 squared is 1. X squared plus, when you square the negative, it goes away, because a negative times a negative is a positive, so I'm just looking at this, that's 2, and then 3 squared is 9, so 2/9. And now I'm going to subtract 2/9 on both sides. This is 9/9. 1 whole is 9/9. So if you take 9/9 and you subtract 2/9, you have 7/9. And now when I square root both sides, I will have x equals. I'm going to write plus or minus the square root of 7 over 3. But the plus or minus is going to be determined by what other information that we have. Here they tell you that x is positive, so x is radical 7 over 3. But the algebra says we might have two answers, so just be aware that when you square root both sides, you should be thinking plus or minus is an option here. Okay, so let's find all 6 values. So the first thing I'm going to do is find the missing side. So to find the missing side, I'm going to say 9 squared plus y squared is 13. So I'm going to do Pythagorean theorem. 81 plus y squared is 169. Subtract 81 on both sides, you get 88. So y is the square root of 88, which can be simplified. Remember, 88, if you make a factor tree, is 2 times 2 times 2 times 11. So if you simplify the square root of 88, you get 2 radical 22. And that's how we're going to write our answer. We need to make sure that we always simplify our radicals, and we'll see in a minute, make sure you don't have any radicals in the denominator. All right, so let's just get this thing rolling here. What do I know right off the bat? So opposite over hypotenuse, that's the sine of theta, is 9 over 13. And now we have the cosecant. Cosecant is the reciprocal of sine. And I know you want cosecant to be the reciprocal of cosine, but it ain't. It's the reciprocal of sine. So you take sine and you can flip it, and now we have 13 over 9. Cosine, now that I know this missing side, I can figure out is adjacent over hypotenuse. So 2 radical 22 over 13. Now the trick to this is when you flip that to get secant, you're going to have to rationalize the denominator. And to do that, you need to multiply the top and the bottom by the radical. So this will be 13 radical 22 over. And this denominator is 44, but let me show you why. Radical 22 times radical 22 is 22, and 22 times 2 is 44. That's going to happen again when I do tangent. Tangent is 9 over 2 radical 22. So when I rationalize that, I'll give my buddy 9 radical 22 over 44. Cotangent is the reciprocal. Now, you can take your answer for tangent and you can flip it, but you're going to work way harder than you are going to work smarter. Here's what I'm going to do. Instead of opposite over adjacent, I'm going to think of cotangent as adjacent over opposite. So 2 radical 22 over 9. It's like, oh, just flip that first step so you don't have to worry about rationalizing the denominator, okay? Sometimes you can save yourself some effort by just paying attention to the ratios and not worrying about so much this, well, I have to flip it and rationalize it. No, you don't. Just flip the sides. Okay? So those are your 6 trig functions. I can do the same kind of thing here, only I give you different information. So what I'm going to do is draw what I call a helper triangle. I'm just going to draw a triangle where this is true. If you tell me the cosine of theta is 5/8, here's a triangle, that's theta. You're telling me adjacent over hypotenuse is 5/8. Now I can do Pythagorean theorem to find the missing side. So y squared, let's see, 25 plus y squared is 64. So y squared is 39. That doesn't simplify. 13 times 3 has no pairs in it. So it's radical 39. So what do I know? Let's see. Cosine. Hey, 5/8. Got that one. Hope you get that one right. 8/5 for secant. So flip that. Sine is opposite over hypotenuse. Radical 39 over 8. Tangent is opposite over adjacent. Radical 39 over 5. Now I'll flip them. So remember, cosecant is the reciprocal of sine. So 8 over radical 39. When I rationalize it, I multiply the top and the bottom by radical 39. And on the top, 8 times radical 39 is just 8 radical 39. In the bottom, radical times radical, you just get 39. Cotangent, same idea. Flip it. So I'm flipping tangent. Now I'll rationalize it the same way. 5 radical 39 over 39. Okay. So you do have to rationalize the denominator. That means I don't want to see any radicals in the denominator. And no decimals ever. So exact answers. All right, let's see. Evaluate all 6 trig functions for the... Okay, we're in quadrant 4. So I'm telling you in quadrant 4 now. So we're adding a little bit every time we do one of these. We're adding a little bit of information here. Quadrant 4 is down here somewhere. So I'm just going to draw a triangle. It doesn't have to be like to scale or anything. Just draw a triangle in quadrant 4. And this is the angle that I'm thinking about. If you tell me the cosine is radical 2 over 3, adjacent over hypotenuse. I'll do Pythagorean theorem. 2 plus y squared equals 9. Y squared is 7, so this is radical 7. Well, kind of. The magnitude is radical 7, but you're in the 4th quadrant, which means you're underneath the x-axis, so y is negative. So it's negative radical 7. That's going to make a big difference. I got cosine here. All right, we got that. Now what else do I know? Sine is opposite over hypotenuse. Negative radical 7 over 3. Flip it. Negative 3 over radical 7. When you rationalize it, becomes negative 3 radical 7 over 7. Secant, 3 over radical 2. Rationalize it. 3 radical 2 over 2. Tangent, opposite over adjacent, negative radical 7 over radical 2. When you rationalize this, you're going to have to multiply radicals. So these are both underneath the radical. You just multiply. 7 times 2 is 14. Stays negative. 2 times 2 is 4. The square of 4 is 2. Cotangent, flip it. Radical 2 over radical 7. It is negative. Then rationalize it. Negative radical 14 over 7. There we go. Okay. So there's your 6 trig functions given one of them and the quadrant. All right, now we're going to take a little detour here and talk about the signs of all these trig functions in different places because we got to make some connections before we do this problem. So it goes back to that triangle I drew earlier. Triangle I drew earlier has an x and a y and the hypotenuse is 1. So if I say, what is the cosine of theta for this triangle? Adjacent over hypotenuse is x. Cosine is just the x coordinate. The sine of theta, opposite over hypotenuse, is the y coordinate. And the tangent of theta is when you divide them, y divided by x. Okay, so knowing those three is going to tell us the signs of anything that we need. Keep in mind, if cosine is positive, then secant is positive. That's its reciprocal. If sine is positive, then cosecant is positive. Reciprocals don't change signs. Same thing with tangent and cotangent. Now what we're going to do is start thinking about, like, in each quadrant, which part of a coordinate is positive. Like in the first quadrant, x is positive and y is positive. In the second quadrant, x is negative and y is positive. In the third quadrant, x and y are both negative. And in the fourth quadrant, x is positive and y is negative. Well, take that idea and now make it the trigonometric version. X is positive. Oh, okay. Cosine is positive. Y is positive. Sine is positive. If these are both positive and you divide them, it'll still be positive. So all trig functions are positive in the first quadrant. In the second quadrant, x is negative. That means cosine is negative. Sine is positive, so I'll say, well, sine of theta is positive, which means also cosecant is positive if you want to include that. Because the y is positive, y is sine. The sine is positive, its reciprocal cosecant is positive. In the third quadrant, x cosine is negative, and y sine, they're both negative. So what happens with tangent? Well, if you divide a negative divided by a negative, you get a positive. So in the third quadrant, tangent is positive, and that means also cotangent. It's reciprocal. Last one, x is cosine, so in the fourth quadrant, cosine is positive, which means secant is positive. The y coordinate is negative, so sine is negative in the fourth quadrant. Now we're going to go through that and kind of apply that here for three different trig functions and what would happen then if you multiply them. So in quadrant 1, sine is positive, cosine is positive, and cotangent is positive. It's going to be positive. Everybody's positive. First quadrant. Second quadrant. In the second quadrant, sine, y is positive. In the second quadrant, cosine is x is negative. And cotangent, so if you divide these two, a positive and a negative, you're going to get a negative. Now, what will happen is those negatives cancel out, and you end up getting a positive. Quadrant 3, down here, sine and cosine, y and x, those are both negative. Cotangent, a negative divided by a negative. Oh, that'd be positive. Tangent is positive in the third quadrant. So these will be positive in the top. They'll divide by a positive. You get positive. Quadrant 4, sine, the y value, sine is negative. Cosine, the x value, is positive. And now we got cotangent. If you divide them, you're going to get a negative. Those cancel. You get positive. So all four quadrants here will be positive. I don't know the numbers, but I know it'll be a positive number. All right. So last thing I want to go over is these are your two special right triangles that you must have memorized. So a 30-60-90 and a 45-45-90 isosceles triangle. If you are on the unit circle, hypotenuse is 1. And what you just need to have very much memorized is across from 60 degrees. Opposite 60 degrees is the long leg, radical 3/2. Opposite 30 degrees is the short leg, 1/2. And opposite 45 degrees is radical 2/2. And since it is isosceles, these are the same base angles, same sides. So radical 2/2. So those two triangles are going to basically determine the entire unit circle. So they are extremely important. Make sure you got that. And why don't you hit that like and subscribe button?